All right. So let me just share my screen. Okay, so hello and welcome everybody to our webinar. We've been planning this for quite some time, and so I'm happy to finally be able to see everybody online. My name's Jennifer Lee, and I'm currently the chair of the Human Data Interaction Committee for the European Council on Computing in Construction. I've been part of the committee since it started, and so I'm currently coming to the end of my reign as chair, if you like, which will rotate to a new person who's currently the vice chair in March. So just a bit of a recap, an overview of what we'll cover today. So you've probably seen this kind of program online, but just a quick kind of coverage. So I'm just going to give a welcome and introduction. I'll talk a little bit about the committee, what we do, and then I'll hand over to Professor Mohamad Kassem. He actually is the person that set up the committee almost 6 years ago. So I thought it would be nice for him to kind of give us a bit more of a background about the rationale behind the committee, and just explain kind of where we've come from and where we're going. We'll then move into our first keynote, which would be from Professor Richard Mortier from the University of Cambridge. And we'll start to hear about the theory around human data interaction, kind of how that came about. So Richard has the seminal paper, I would say, on human data interaction from a theory perspective, which is something that we really build on within our committee, and try to make it more relevant to the built environment, and which then takes us on to the second keynote, where we have Kohvakka and Dimosthenis Kifokeris from Chalmers University and in Sweden, all the way around, I think, who will talk about their experience of using generative AI in terms of human data interaction. So this is an industry academia collaboration, followed by our third keynote with Burcin Becerik, hopefully I pronounced that right, who is currently in LA at the moment. So thank you for joining early in the morning, and she will talk about her work on human building interaction. And then we'll close out the session with any time that we have left, where Mohamad will take over and chair the panel session with the speakers. So I would ask for people to put questions in the chat as and when they come up, and then we'll hold all the questions until the panel session at the end. And we'll coordinate those questions at that point. Hopefully that's clear. So in total, the session will take around 90 minutes. And hopefully you will walk away from the session with a bit more of knowledge and kind of be more informed about the concept of human data interaction. So the first part then is just for me to give you a very quick overview of like who we are as a committee, and some of the things that we do. So we are one of 4 committees within the European Council on Computing and Construction. You can see on the website, which is ac3.org, I believe, the other committees and how we sit within that kind of framework. But essentially, we are a technical committee that was set up to research human data interaction. I'm not going to go into too much detail about the rationale behind it, because I think Mohamad will cover some of that. But just a little bit of an indication of who we are and what we do as a committee, with the purpose being that if you are interested and you want to find out more, there are details at the end of my presentation just now, how you can contact us if you want to become part of the committee and just kind of do more in terms of human data interaction. One of the things that I'm very happy to share about today, and actually other members of the committee are not aware of this because I only had the news today, is that our white paper that we've been working on since we started the committee has been accepted from the second round of reviews. And so we're now working to publish this as soon as we can. So we've been through quite a rigorous review process, and you can see here we're kind of pushing out this kind of first white paper for the committee that looks at human data interaction across a number of fields. So we started with identifying what human data HDI is for the built environment. We have a working definition for that. And then we looked at HDI in the context of a number of different areas. So censored construction sites, smart buildings and cities, robotics, VR and AR, machine learning, deep learning, artificial intelligence, and also blockchain. So this is obviously not a exhaustive list of areas that we look at in terms of HDI, but it was a starting point for our committee, and our other ongoing projects will start to look at other areas within HDI. So as soon as that white paper has been formally published, we will publicize that across all of our social media channels, and it will be available to download from the EC3 website in due course. And we're very happy about that. So very big congratulations to all of the authors and the editorial team, Mohamad and Dimos, for kind of bringing that together in the last few months. So one of the projects we've got ongoing at the moment is an underlying theory of human data interaction. So this is taking the work that Richard will present today, and we're kind of trying to look beyond that and make it more specific for the built environment. So we published a paper at this year's 2024 EC3 conference. We have a relatively large team working on this project of people who have primarily been with the committee since the start. And the idea is just to build on previous work, focusing on built environments specifically, and then would use that as a basis to kind of springboard for other projects going forward for the committee. And it's based on primarily literature review at this stage. So we did publish this paper this year, and the idea is that we will extend this work going forward into a number of journal papers that will build on the theory that we've started to kind of develop. Another project we have ongoing at the moment is looking at the adoption of artificial general intelligence in the building industry. So this is a project that's being led by Xiang Jie from Newcastle University, who is a member of our committee. And the idea is to look at the use of AGI across the built environment and the building industry to understand how we can start using it to reshape communications, decision-making processes, and so on. And I think there might be some correlations today between what Dimos and Jan talk about in terms of kind of what's involved in this project as well. So the idea is that this team of people will be working on an initial paper that will be published at next year's 2025 conference. And then from the point that the paper is submitted in December, there will then be discussion around how that project is taken forward. Other things that we have been discussing in the last few months are projects around digital twins, thinking about now that we have the white paper very soon to be published, what will we do with the content of that in terms of taking it forward, with maybe extending some to different to technical papers or additional kind of subject areas that we want to focus on. Looking at how we can boost our industry collaborations with the committee. So I think we've got a lot of interesting things coming up in the next year. One thing that is I'm very happy to announce is that we are kicking off now from the 2025 conference with a human data interaction track at the EC3 2025 conference, which will be great. Our vice chair, who will soon to become the chair, Diego Salvetti, he will chair this track for the EC3. So if anybody is interested in conducting research on HDI, obviously you don't have to be within the committee to do that, but we would encourage, do engage with us. It's something that we're particularly interested in. And these are the themes here that we would cover, but we're also not restricted to those. So I guess this is a call for HDI specific papers for the conference, which could be a really nice way for you to kind of start expanding your knowledge in this area. Typically, the deadline for full paper submissions is December. And depending on how submissions go, it's likely that it may be extended for a couple of weeks or something, but generally we work on a basis of December. So we're very much open to discussions for collaborations on papers, but of course, you can, if you are interested in this topic, do feel free to explore this in more detail and submit papers for next year's conference. Very quickly then, if you are interested in joining our committee based on what you hear today, do get in touch. We have a scheduled committee meeting that takes place in September, the 27th of September, which you'd be welcome to join, even if it's just to decide if it's something that you think you're interested in. But essentially, within the committee, we have a number of roles. So the chair, for which I am currently, the past chair, which is somebody that just provides guidance and remains part of the committee. during their kind of after their chairship. We have a vice chair, secretary, and then a member. So the first 4 roles you see here rotate every 2 years. So in March, at the annual general conference for EC3, I will become past chair, Diego becomes the chair, Mahir, who's currently our secretary, will become the vice chair, and we will be looking for a new secretary to come in as part of the kind of the leadership team, the management team of the committee. Members will be asked to sign up for a 2-year period. And all we ask is kind of engagement. We really like to have people who are very engaged in the committee to attend committee meetings and contribute to projects, propose new projects, and so on. So do get in touch if you are interested. Our contact details are here, but I think most of you should be able to contact me either via email or LinkedIn at any point. So without further ado, I will now hand over to Mohamad, who will talk us through a bit more about the committee and how we kind of came about. So thanks very much, Mohamad.
Thank you very much, Jenny. I'll share my screen. Is it shared yet? Not yet. A second. Okay, thanks a lot, Jenny, for the great introduction and also for putting together this event. It's really well organized and very interesting topic. So like Jenny said, I just take you through the rationale behind the committee, how it was formed and what happened since we formed it, what was the motivation for forming it, and what we are trying to, in terms of content, in terms of focus, what we are trying to do as a committee. So to start with, basically, you know very well, you know, if we talk about the physical world, and with physical world we refer to built environment and occupants, human living and interacting with it, is generating a huge amount of data. I tried to look at how much data it's generated daily before starting the presentation, and the number is like really something like more than 400 billion gigabyte daily. So it's a huge amount of data. So if we look at the built environment and construction, and with construction here, I think something to clarify for people attending, we don't refer to construction as a construction phase. We refer to construction as a built environment as a whole, and to the process of designing that built environment, building it and operating it. So that's what we refer to in construction. So this built environment is no different. Basically, it's generating a huge amount of data at every level. If you think about, you know, like a small pump within a building to the HVAC system in its entirety, the building itself, the urban district or the city as a whole, they are generating a huge amount of data from various digital system and IoT technologies. Again, I looked at the data about like what a smart city would generate a day in terms of data, and a smart city for 100 million inhabitants. So it's not really a big smart city. It generates around 180 million gigabyte daily. So it's really a massive amount of data. So despite all of this data, I think when we talk about construction specifically, we are not making a huge benefit from that data. We have lots of, there are statistics that say 90% of that data remains unused in construction. So there is a huge opportunity really to untap this wealth of data to generate insights that help us to understand, you know, how the relationship between the built environment and humans is evolving, is changing. We could inform, you know, policy making. We could strive to achieve better societal outcome. We could develop new services. We could improve existing one. All those things are really key, and data can help us to unlock these things. So I wouldn't. I mean, we have great speakers today who are world leading in data, data in theory for HDI. But I just want really to throw a few concepts that maybe they will fuel the discussion, and we will hear about them later on. So we generate data through intentional action. So we do deliberate action. We, as a building occupant, we might be triggering the thermostat through our building management system. That's a deliberate action. We could be engaging with community engagement app, reporting potholes. That's a deliberate action, so intentional action. But we could also generate data from unintentional actions, the mere presence of in a building where there are, or in a space where there are camera system or CCTV. We generate data. We generate data through our mobile phone unintentionally, like Wi-Fi usage and our location and so on. And we could be, as human, we could be producing data, we could be consuming data. Data could be primary in terms of raw, not treated, or could be derivative. And this is really where there is a huge journey from raw data to derivative data. I'm sure Demos and Jan will be talking about AI in this space. So that is as well, I could have added another bullet point, human as data handlers. There are lots of concepts that are really emerging in this space that need some theoretical thinking to understand how they're evolving, what roles they can play, and so on. So what type of interaction we could have? Really, interaction are, there are many types of interaction. If you take just as an example IoT, look how many example of interaction you have. You start, for example, with the top one. I'm not going to explain all of them, just a couple of examples, like the example I gave earlier about a building occupant interacting with a BMS system to change the temperature in a building. That's IoT, human IoT. You can go all the way down to IoT, where, for example, in traffic management systems, where two subsystems are interdependent. One system detects there is a traffic. It instructs the other system to divert the traffic. Those actually are existing system. If you think about the smart motorway in the UK, they are kind of IoT type of infrastructure. So what this has implication? This has implication in terms of what interaction basically in terms of autonomy, agency, and I'm sure Richard will cover these kind of concepts, but also in terms of ethics and safety. I know I wouldn't talk. This nothing has to do with politics. I'm not sure if any of you have watched the news over the last half an hour. There was an incident, first of its kind, I think, in the humanity. Basically, Israel managed to detonate in Lebanon thousands of devices remotely, and there are currently in Lebanon about more than 1,200 people injured all across Lebanon. They were detonated at the same time, and these devices are telecom devices called pager. They use them in healthcare when like the telecom network goes down. It's unbelievable. These are the things like why I put here safety. So there are really huge implication on currently in the way we in the world we live in to safety and things like that. So what's the motivation of the HDI committee giving all of what I showed before? Is really we started with simple statements about our motivation. We would like to investigate how interaction between human and data are changing. And we would like to do that at different asset levels, those asset level I mentioned before, and project phases, so design, build, and operate. And this is really key. We can unlock various insight in field such engineering, social science, but also in management. So why we opted for HDI, why we didn't, for example, stick with human-computer interaction. Is human-computer interaction not good enough for us as a terminology to keep to staying beneath it? The reason for that is if you look at the various like acronyms we have here, human building interaction, human robot interaction, and so on. I think it would be really stretching too much the C within HCI to cover all of these things. I know HCI scholars who's been in HCI for a long time, 15, 20 years, they are trying to extend the connotation of human-computer interaction to include all of these things. I personally disagree because it's like the same thing ongoing currently with those who are extending, at least those who are familiar with BIM, trying to extend BIM to bring digital twin as part of BIM. So it's the same analogy. So we thought the common denominator between all of these things is really the data and interaction. So that's why we opted for human data interaction. Like Jenny mentioned, the white paper, we have a working definition. Maybe Demos might have that in his presentation. So that's why we selected HDI as a term. So in 2019, EC3, the EC3 is the European Council for Computing and Construction, decided to launch a HDI committee. It was the first. They asked me to chair that committee. It was the first committee. We formed it in 2019. And really, I have to say, since we launched it, we are learning about HDI, and this event is great to bring some really very well-known scholars in the space to learn from them. We don't, I mean, we can discuss, like Jenny said earlier, we have this white paper coming up, but it's really, we wrote this white paper while learning. All of us were learning as a committee, so we don't consider ourselves really top expert in this space so far, but we are learning, and we are, we know how important it is, and you have seen some of the interesting projects that Jenny mentioned. So in terms of how we structured ourselves, and this is really key, we structured ourselves to investigate topics at 3 levels. If I start from the right to from right foundation, it's like theory focused. Some of the stuff I think Prof. Richard Mortier will present falls in this space. So identifying really looking at theories, methodologies related to HDI, framework for analysis, and so on. Then we move to development. Development is about looking at, like it's more technology focused, like how we can developing new technologies that change interactions, that improve interaction, but also testing of existing technologies. And finally, we have understanding. This is user focused, is basically trying to understand how user behave, how user interact, trying to understand the societal implication of this new interaction, and try to develop as well new use cases for ICT, for emerging ICT and emerging technologies. So this is how we structured ourselves. And in terms of scope, we work at 4 levels, or not work 4 levels. We engage in 4 types of activities. We really would like to be lead the research debate around HDI when it comes to engineering and construction projects, specifically in built environment, liaise with relevant industry and policy stakeholder. And things like with Horizon or European Commission on potentially on lobbying them to fund the project in this space. We would like to play, of course, a key role in developing research roadmaps for, like the white paper falls in this space. And we support, like Jenny mentioned, existing and new conferences in relation to HDI topics. So that's really all that I wanted to say. Thank you very much, Jenny, and thanks for the audience. And I'll give you the floor back to Jenny. Thank you.
Thanks, Mohamad. That's really great. I think you really captured, I've been part of the committee right from the beginning. You asked me to join as a secretary, and yeah, I think that's a really nice overview and just gives hopefully a good introduction about who we are as a committee, kind of what direction we're leading in. So next, we are going to move to Professor Richard Mortier, who will start to really kind of uncover some of the issues around the theory. So I'm going to share this screen. And I think, yeah, Richard, if you just let me know when you're ready, I'll move on to the next slides for you.
Great. Thanks, Jenny. So just before I start, thanks for having me. It's quite flattering to hear that something I did a while ago is sort of becoming of interest and being used by other people. I thought I'd start by giving a very short introduction to kind of where HDI came from, as far as I was concerned, as far as the people I worked with on it were concerned. And then I'll go into a bit of just sort of general background and touch a little bit on one example, slightly tangential example of where we've kind of been thinking about that and how it's been turning into research we were doing in the built environment here in Cambridge in the systems group. So my background's a technical computer scientist, so operating systems, networking, network protocols. I moved up to Nottingham University to work at an institute called Horizon Digital Economy Research. And they were set up to do research into the digital economy with a particular focus on personal data and uses that could be made of personal data. So that's why a lot of the writings around HDI that I did when I was there tend to focus very much on the individual and on individual personal data and personal data sources, social media and so forth. But as I hope it's proving to be the case, it's a more general idea, I think, than that. It doesn't have to just be limited to those sorts of data. So where it came from then was this idea of personal data privacy, personal data processing, and a sort of realization that we came to in the course of thinking about what digital technologies could be developed to help people make sense of and use effectively their personal data. It's about the data flows and the effects of the data flows, rather than about the devices specifically that you interact with. So this, I think, is where it's it's stepping on from traditional HCI, as at least I understand it, as somebody who came into the field quite late, I guess. The description of it that was given to me is that HCI has gone through 3 phases, essentially. So the first phase was very much about the person and the machine. So it's one person, one computer. How do you make the computer possible to use effectively? And then as computers developed and computer technology developed into the 80s, I guess, 70s and 80s, you started to see computers being networked, being used in work environments, workplace environments, and being used collaboratively. So there was a need to study how to make digital technologies effective in collaborative environments where you might have multiple people collaborating on a single task using digital technologies in that environment. And that was phase 2. Phase 3 then is sort of where we're at the moment, which is much more around kind of design approaches, where you're trying to delight the user. It's very discretionary as to how they spend their time. They don't have to use the technology for a work environment. It's got to fit into their everyday lives in a way that requires much more design thinking and less about sort of time and motion studies and making things efficient as such. And that's kind of phase 3 where we're at. And so I guess when we were thinking about sort of personal data and personal data interactions and how to use that effectively, we started to think, or I started to think, that this was more about the data and less about the machine. So it's not about the devices. There's lots of different sources of data, lots of different uses of data, and lots of different effects that data can have that are not limited to a single machine or even a single system or a single company relationship. It's sort of in everyday life now. And it becomes quite complex to think about that as a result. And so HDI was our attempt to approach that and start to think about what that could be. With that, could you turn to the next slide, please, Jenny?
Yeah.
So this was the sort of the very, very high level model we came up with when we were discussing this. So it's almost ridiculously high level. Essentially, the idea is that you've got personal data being generated by the person sitting there in the left-hand corner. There will be many different sources of that data. They may be so-called real-life sources, credit card transactions, shopping preferences, loyalty card data. It could be from sensors in the environment, Internet of Things sensors, data about your use of electricity and energy in your house, things like that. It could be financial data. It could be online data. It could be social data, email. There's lots and lots and lots of different sources, but generally speaking, thinking of them as data. Those data are then taken into analytic systems, which analyze the data. And having analyzed the data, they produce inferences. So typically, these are not kind of deductive facts that are generally taken out here. They'll often be inferences. They'll be statistically accurate things that have been computed from the different sources of data that are available about you. These inferences and the inferencing process is often very opaque. It's not clear what data is being consumed to produce those inferences, and it's not clear how those inferences work and what they're doing essentially to produce the outcomes that they produce. Having drawn inferences, these will typically be used to generate some kind of actions in the system. So that might be sending you special offers, it might be giving you discounts, it might be turning on your heating in advance of you coming home. There's all sorts of different things that can be done as a result of that. But essentially, it's data feeds analytics, analytics produces inferences, inferences produce actions, effects in the world. And those actions kind of feed back in 2 different ways. One is that they may affect our behavior. And so we then go on to produce different data as a result of the actions that have been carried out by the system, thinking of system in a very kind of broad, fuzzy sense. The other is that those actions may actually take the inferences and feed them back in as more input data. So you kind of have these different models and processes feeding off each other to produce more inferences, which can produce more actions. So you've kind of got a you've sort of got a feedback loop here where behavior in the world is causing data to be analyzed, inferences to be drawn, actions to be taken that then generate and create more data in the world. And our thinking at the time when we started to try and unpick some of these things was really the best phrasing we could come up with for this was this idea that they lack, these systems lack legibility, agency, and negotiability. I was reasonably happy with the words legibility and agency. I think they're fairly well defined and obviously understood. I think negotiability is firstly an ugly word, and it's also not quite so clearly defined. But I'll try and go through what I meant by those now. If we could go to the next slide, please. Sorry, Jenny, could we go to the next slide, please?
Is it not?
Not
on my screen, I'm on slide 3 with lack of legibility. Do you not see that?
I don't. Mohammed, can you put your thumb up if you can see slide 3?
Let me, maybe if I stop sharing and then start again.
Yes, I can see lack of legibility. Yeah.
You can.
Okay, that's fine. I have the slides here on another window, so I'll just ignore what I'm seeing on the Teams chat. So as long as everybody can see slide 3, lack of legibility. So what we were trying to get at here was that people talked at the time about. Oh, Teams is caught up. Thanks. People talked at the time about the ability to understand, to be able to see. Sorry, to be able to see what was going on and see the sources of data. And we were trying to get at something a little bit more than that, where it's not just about being able to see things, because you can be shown some system that's extremely complex and it can make no sense to you, and it's not very helpful to see that. We were trying to get to the point where it actually has to be understandable. So you need, ideally, you would want in such a system, the individual people who are data subjects to be able to see and understand what the data sources are that are being collected about them, and what the analyses are that are being performed on those data, and then indeed what the implications of those analyses might be. So what effects could they be having in the world? At the moment, the system is extremely opaque. It can be very difficult to understand what data is collected. It's usually proprietary. It's very difficult to see what analyses are being done, and it's very difficult to understand what the implications of those analyses might be. And they can be quite severe. I mean, ranging from not getting a job interview because somebody's auto-processed your CV, through to changing your credit card, your credit scoring, through to denying you a mortgage application. There's lots of big effects that these systems can have, and we thought it was important that they should be both visible and also understandable, comprehensible to the people that were data subjects. Next slide, please. So the lack of agency. So agency is about the capacity to act in a system. So if you have agency, you can do something that will affect the system in some way. You're not completely shut out and it's just being done to you. So the sorts of things we were thinking here is that, given that we're unaware, we're basically typically, even if there are means that we have to affect data collection and that affect data analysis, we're generally unaware of those means. They may not even exist. Even when they do exist, they may not be obvious to us that we can exercise those means to affect data collection and affect data analysis. And we may not understand the system well enough. If we don't have legibility of the system, we can't understand the system well enough to understand how to employ those means that we might have. So how to control what's done with our data, how to correct data that may be wrong, how to sort of step in and interact with the system in a way to exercise some control, exercise some power in the system, rather than just having things done to us by people who are in a position to collect data and analyze it at scale. Next slide, please. So the next one is about negotiability, which, as I said, is a slightly ugly word. But really what we were trying to get at here was the idea that these systems are dynamic. So you need to support for dynamics. You need support for dynamics of interaction in the systems. So even if you have legibility of the system and you understand what's happening, and even if you've been given some ability to control and influence what's happening, so you have some agency, it's often the case that the way the system is initially framed and initially deployed kind of traps you into a particular framing, and you can't change that. So, for example, a system is put in the marketplace, Gmail, Facebook. It has terms of service. You either have to accept those terms of service to get the service, or you reject them and you don't get the service. You have no means to go somewhere in between the two, or to say, well, I like this, but I don't want that part of it, and I'm willing to give up this element of the service. You start to see that more now than when we were writing this originally, whatever it is, 10 odd years ago now, where you begin to see things saying, well, if you want personalized adverts, we have to be able to process your data in this way. But if you're willing to have generic adverts that are not personalized to you, then we won't process your data in that way. So you begin to see slightly more capability to negotiate in some sense with the service provider to have a sort of richer set of options available to you. Having said that, it is even now still sometimes quite difficult to modify or refine those decisions after you've taken them initially. So you might be able to opt out of processing, opt into processing. It's not always clear what happens to the data that's already been processed, the models that have already been built, and the degree of control you have over those kind of things. And it's also, even now, it's not always obvious, even when you can make these choices between, for example, personal data processing to get personalized and hopefully more relevant adverts. it's not always clear what the data sources are that are being used to do that. And as the data sources change over time, as new data sources come online, as companies acquire other companies and have access to more data than they had previously, it's not always clear to you that that is happening and that that has an influence and an impact on the data processing and data analysis that can be done, and so the inferences that can be drawn. So that was an attempt to try and sort of set out what those three pillars were that we put together in that original paper: legibility, agency, and negotiability. There may be others. There's other people who have started looking at this over the last 10 years or so and come up with other ways of looking at this and other elements of this that are important and seem to be critical. So I think these are being extended, but these were the ones that sort of we started with. Next slide, please. I thought I'd just say 2 words on one of the things that this drove us towards in terms of technical approaches to try and support HDI at a very kind of low level platform level. As I said, my background's in computer systems technology, so operating systems, networking. So I tried to think in terms of platforms and what are the minimum sets of capabilities you need at the bottom layer of the system to support the things that you would like to have above that, support the application level and the application level capabilities you want. And one of the key observations I think that we made is that basically all existing systems that were current at the time, and most of them now, again, this is changing slightly over the last couple of years, move the data around. So it's essentially cheap, if not free, to many people's perspective, to move data. And so you tend to see data being taken from sensors that are deployed around the world, whether it's mobile phones, whether it's IoT sensors, whether it's data sources in banks, credit cards, etc. And that data is taken from where it's generated and moved into the cloud. And as the bumper sticker has it, the cloud is just somebody else's computer. So data is being taken and moved into large data centers operated by corporations, often very, very large, very rich corporations. So they're taking data at scale, bringing it all together and doing lots of analysis and processing of it. That is fundamentally giving up control over the data by the data subjects. Once the data is taken away from them and put into some large data center somewhere, it's very difficult for them to exercise control over what's done with that data. This is changing a bit. You're starting to see more capability to manipulate the accesses to data to allow people to process data or not. It's still fairly coarse-grained. It's often difficult to understand, and the controls you're given are often quite dynamic and therefore difficult to configure and keep reconfiguring to what you would like. You're also starting to see, and this is more in line with the way we were thinking, approaches such as federated learning, where more of the data is being processed on the device that generates it. So data is being processed on mobile phones, for example, and machine learning and data model inferencing being done on the mobile devices themselves, rather than having to backhaul the data to some centralized location to process it there. So you're beginning to see this change a little bit. But at the time, it was definitely the case that data was basically being taken into data centers and processed. And at that point, you lost all legibility, you lost all agency, you couldn't do anything with that or control that in any way. It was now up to the company to do what it wanted. Next slide, please. So the alternative approach that we tried to look at was to, rather than moving the data to the code, move the code to the data. So the idea is that if you keep the data where it's generated, typically on a device, we did have a project called DataBox, which tried to build such a device and set in place a processing framework that would allow for sort of legibility and agency of control over what was going on. The idea was that what would happen is you would be in control of that. So you would control the device that had the data. It would not go to some big data center somewhere in the cloud. And instead, the people that wanted to process your data would send you pieces of code that you would be able to inspect in some way, or at least the platform would give you inspection points, if you like, to tell you what the code was doing, what data was being accessed, how it was being accessed, how often it was being accessed. And you would be able to look at that data, look at that metadata, if you like, and understand what was happening to a much greater extent, and potentially even control the release of results of that data processing. So rather than releasing the raw data, after which point you can't control what's done with it, instead, you can control the raw data. Somebody sends you a computation, you run the computation. If you're comfortable with what it's found out about you, you can then send that result back to the person that asked for that data to be processed. So you are now retaining control, complete control in some sense, of what is done with the data and how the data can be used in future. You're not giving the raw data up. And sort of inverting the problem like that by saying, let's move the code to the data instead of moving the data to the code, it felt like you gain a lot more control over what can be done and how things can be processed. It does make some applications much more challenging. You have to think a lot more carefully as somebody writing that code about exactly what data access you need and when, and at which points in the computation you're carrying out do you need to bring results together and bring data from multiple sources together. So it makes that a bit more complex, but it does enable this much greater control of what's done with the data. And it has a number of other benefits in terms of when you start to scale this up, you're moving less data around. That may well be more efficient, particularly if the devices generating data are small devices at the edge of the network, but there are many, many of them, or they're generating high bandwidth data, such as video data. And you also obviously retain much greater control over the privacy and the privacy implications of this. This sort of approach became PDS's personal data systems, personal data management systems was the kind of the generic term that was coined for these kind of systems. Next slide, please. So one very simple example of this that we built over the last few years in Cambridge was part of the Centre for Digital Built Britain work that we undertook. So it was a camera called Deep Dish. So this is essentially a smart camera for counting people either side of the virtual line. It's local processing of the video feed. So that rather cute, I think, rather cute looking box at the top there always reminds me of the robot from Short Circuit 25. So that's a Raspberry Pi in a box with a camera attachment to it. And I think there's also a local GPU on a USB stick as well for increasing the processing. And that is able to do local processing of the video feed from the camera so that the only data that needs to be emitted from that device are counts of people on either side of a line. So there's no personal data going out from that unless you can infer something because you happen to know precisely where that camera is and it's in a very restricted location. But basically, you cannot see data about individuals. You can only see counts of people. There are other systems that do similar things where you're doing object recognition in the camera effectively that you can then count buses, cars, bicycles, people, and things like that. So it avoids the network costs and the privacy risks of transmitting the raw video. And this is an example of sort of edge-based processing, which I think fits more generally with HDI as an approach, because you're trying to keep the data local, reveal as little as possible, move as little data around as possible, and do as much processing as you can locally. Next slide, please. So some of the things that we found out in the course of the projects that we did under this sort of banner of HDI, I guess, one of them is kind of obvious, but it wasn't obvious to us just how complex it was, is that data sharing is complex. Sharing data is difficult to do. It's difficult to do while maintaining control of that data. It's difficult to do in a way that people can understand. Some of the challenges we came up with in the course of the DataBox project particularly were things around legibility. So how do you visualize your own data in such a way that you can make some sense of it? In fact, it's worse than that in the sense that I've used the word data fairly generically through this talk, but of course data is not generic. Data is specific. It comes from a specific source and encodes specific information. And the sensitivities around photographs are quite different from the sensitivities around email, quite different from the sensitivities around energy consumption. All of those may contain personal data. They may infringe privacy in different ways, but they do so in very different ways. And one of the, I think, realizations we had in the course of the project is that actually thinking of data in too generic a sense is a really unhelpful starting point. It's always better, I think, to try and be specific about what actually is it that you're dealing with. And then maybe there will be commonalities with classes of data or classes of data source. But to start out trying to think in generic terms actually doesn't, it's often unhelpful. It makes life difficult. There's also a need to think about data that may not be visible yet, either because it's private and it's going to become public, or because it's not yet been collected, but it's a public data source that will be collected in the future. And so the number of attacks you can do that generate privacy infringement on a data set that once was perfectly reasonably private, but by combining it with another data source, it allows you to undo that anonymity or privacy is quite difficult to manage and difficult to control, which is one of the reasons fundamentally, I think, why keeping the data local and not releasing the raw data is kind of the only way to really handle that sort of challenge. There's a need to deal with how you present data to data processors. What degree of control and ability to edit the data do you provide? This notion of recipient design was one that I found quite useful. So it is apparently the case that essentially data sharing between people in a sort of social science sense is recipient oriented. So you think carefully before you share information with somebody else. And whether you were willing to share that information with somebody else will depend on multiple factors, which might include who that other person is, the context that you're in, and obviously what is the data or the information you're going to share. So there may be things that I would say to a work colleague in the office that I would not say to them in a pub. There may be things I would say to my wife at home that I would not say to her if we were out in the shops. There's a lot of contextual dependency in terms of how you go about sharing data and what data you're willing to reveal to other people, and in what context you're willing to reveal that. And that makes the whole space very complex to design for, I think. The second sort of set of challenges were around user-driven discovery in terms of this. So basically, who is discovering what about whom? Who is discovering and how are they discovering? What data sources exist about you or about this from this building, for example? How do you make those data sources available for consumption in such a way that people have to make appropriate requests to get access, but they can still find out what there is to ask for access to? This kind of pointed, I think, towards a need for metadata standards around data sources and data processing as well, for analytics to work out who's using what, how much they're using it, when they're using it, to also potentially allow for the ability for data subjects to exercise control in some kind of potentially some permission system around, are you specifically able to use this data about me for the purpose you're trying to use it? There may be other techniques for sort of social ratings, data exchange, the ability to do more than simply say, yes, you can have access, or no, you can't have access, that would assist with that discovery process. And then finally, and this was kind of some of the gnarliest problems I think that we encountered, was thinking about how we go from data being about me to data being about us. When we stop to think about it, we realize that actually even most personal data tends not to be about a single person. So people think of their email as private, but emails usually got at least one sender and at least one recipient. So it's already involving at least two people. Most people who have, or many people who have bank accounts, financial transactions, in many environments, those will not be just their own sole transactions. They'll be in a family environment or a group environment, or there may be some kind of, I don't know, group kitty going on. There's ways in which we financially interact with other people where that data involves more than just us. IoT sensing, I think this is particularly true in the built environment and probably the construction industry as well, where it's very rarely the case that you have a sensor in a building which is taking data that's obviously only under a single person's control and only concerns a single person. There will be visitors, there will be other occupants of the building, there will be people coming in and out all the time. And so this kind of data is, even personal data, is not solely about a single individual. Makes this whole thing more complex, because now you have to deal with the cases where you need to delegate access or delegate control over access to other people. You may need to revoke control and revoke delegation. You may wish to have some kind of consensus mechanism that means that some people who are the subjects of a data set are able to give access to that data set where others are unhappy about that. It may be unclear about how that data set can be subdivided between those people who are the subjects concerned by that data set. So that it gets very kind of, again, it gets very contextual, very specific about what exactly is the data, what exactly can be done with it, and how should you think about who is able to control it. It gets worse when you start, as soon as you start giving any data away, you lose control over it. So the transitivity of this becomes complex. If I pass data to you, you can pass it to somebody else. How do I control that? Can I control that? And how can I track the uses that are made in the future of the data? How can I track what's being done with it? Particularly in an environment where other data sources are going to become available that I'm not aware of at this point in time, which may change the decision I would make about sharing some data or allowing some data to be used. So that the entire space got really complex really quickly, I think. And I think that's kind of all I was planning to say. I hope I've not overrun too much. On the next slide, there's some links to some projects and some papers that we came up with or put out at the time around this kind of space.
That's great. Thank you so much, Richard. That was really interesting. And I think it's really nice to be able to contextualize the theory with some examples that, you know, most of us in the built environment are kind of familiar with. So yeah, I really appreciate that. We are a little bit behind time, so we're going to move straight on to our next presentation. Just a quick reminder that we will do questions at the end of all of the presentations. So do write your questions in the Q&A, and we will address those kind of at the end, so that you don't forget the questions that you have. Put them in the chat, in the Q&A now, and then we can look at them towards the end. I'm going to hand over now to Jan and Demos, and they're going to talk to us about their project using generative AI and how that integrates with HDI. So thank you very much, and over to you.
Thank you, Jenny. I hope we are heard well, right? I will share the screen, so we will share this presentation with Jan. And so here it is. So just give me a moment, please. Right. Okay. So I would say that what Richard just led us into is it was a very nice introduction of some fundamental concepts and concerns about HDI. So what we are going to present to you, along with Jan, is a kind of a contextualization of these concerns, along with the work that has been done in the HDI committee of EC3, in a specific topic and specific tasks that involves generative AI and large language models in the built environment, right? And through this highly contextualized example, we will try to share with you an interesting story. We hope it's really interesting and enlightening for you. And also we will share what we learned through this collaboration between the industry and the academia, and how it can reflect our considerations regarding HDI. I'm Burcin Becerik-Gerber. I'm an associate professor in Chalmers University in Sweden. Very sunny today in Gothenburg. And Jan, would you like to introduce yourself as well before we move on to the next slide?
Sure. My name is Jan. I am the only one here, I think, from the industry. So I'm not as smart as you guys. So it's good to be surrounded by all of you. And I work as an innovation lead for a company called Incord, and which is basically a MEP company. So we do all design work for various types of buildings, and in different disciplines as well. That's
That's
a quick intro.
Yes. So you're probably the most interesting person in this seminar already, or the most unique. But I mean, Mohamad already led us into earlier that I was planning to talk about the working definition of HDI in our white paper. So, I mean, and trying to be as accurate as possible to the actual definition that we have in the white paper. HDI, or human data interaction, in the context of our understanding, is the interaction between the bundle of interactions between actors and data throughout the whole life cycle of a built asset. And this life cycle can include the planning, the feasibility study, the design, the construction, the production itself on site, and then of course operation and maintenance until the decommissioning of this built asset. And the reason for this understanding, the understanding of those interactions, is for us to be able to obtain to understand the economic, environmental, societal outcomes that these interactions generate, and also to be able to obtain value and benefits for such interactions that would positively impact or affect both the parties that are integral, that are active in this interaction, that are involved in these interactions, but also to the parties that are affected by it, even if they are not active parts in this bilateral interaction between humans and data, right? So this is the working definition. I think it's much more slim in our white paper, but I furnished it a little bit more with some more words. And in our idea of making this working definition, we based ourselves in a lot of both seminal and current literature and theory behind it, including Richard's papers. So the three principles of legibility, agency, and negotiability, which are the pillars of HDI, Richard already talked about them. But now the thing is this: through the story we're going to tell you with Jan, through our journey, you will see that, or at least we are letting you into this already, that the part where LLMs and generative AI for the context of the construction application we're going to talk to you about, we think that the most prevalent, let's say, of the three principles is the one of negotiability. So if we're talking about negotiability in the context of being the ability to reevaluate decisions as contexts change, we believe that we learned through our work and our collaboration in between industry and academia that LLMs and generative AI and the combination thereof for construction applications can really tap on this specific principle a lot. And this is, I think, where the interesting part of our story goes. So before I tire you too much, I'll leave you to the capable hands of Jan before I come back again. So here you are, Jan.
Next slide.
Right.
Okay, thanks. Yeah, so a little bit of background from, why we are here, why we are today. And so back in, since 2018, pretty much we've been working with trying to improve quality in construction projects. And why would we do this as a company? It doesn't really make any sense, but we've been working on our own system for quality assurance and self-inspection for a very long time, and basically realized that this is something that only benefits us, but the project still, it's bad quality in the end. So why not do the only sensible thing is to create something where everybody can participate? And when I say everybody, I mean contractors and designers on the same platform, and essentially the client as well. Because if we can do that in a very nimble and smart way, we could create a lot of data that could be used for improving quality in the long term, and also benefit the project as a whole. So the vision that we've been working towards is basically to make self-inspection and quality assurance more value creating and fun, which it's not today, at least not in the Swedish industry. But it could be so much more if it's been used in a sensible way, in a good way. And self-inspection, for those of you perhaps not familiar with the concept, is that both contractors and designers are, they have to verify what they're doing, that their work complies with regulations and also project requirements. And this is not seen as a very value creating thing in general, but it could be so much more if people actually start using this as something that's creating value instead, because it's basically one of the only ways to assure that, or basically to prove that the work that you did was done in a proper way. So we started to look at this back in 2018, and back then we didn't have these models that we have today. I think Google came out with the BERT model, which I remember when I was looking at it, I couldn't really understand what it was and what it did, but I was very impressed when I saw that it could actually understand text, and understand text more than just understand what words were in a sentence, but it could also understand a deeper meaning. And this made me think about, realizing what the future could be if we could understand text in a better way. Then we could extract things from that text and not necessarily generate things, but to understand more thoroughly what kind of data is being created and stored. So, and the reason also why we did this is because errors and deficiencies and damages cost a lot of money annually. And one reason for this is that the quality assurance doesn't really work the way it's supposed to do. So that's when pretty much I met Demos back in 2018, and we started our first project. And since then, we've been working through 4 innovation projects, and that puts up till up until this date, where we just finished our last project that was focused on the use of AI. So I think you can continue with the next slide, Demos.
Yes. So, I mean, in the beginning, this projects, the premise of this project was that we wanted to, as Jan explained, we wanted to find ways to tackle the problem of construction, the problems that construction quality exhibited in Sweden, right? And do this in a data-intensive, but also at the same way, intuitive and fun way. So we experimented on how to do this, working in the context that we worked and having like the industry framework that we did and the industry constraints, but also opportunities that we had. We tried to find things to do this. And I mean, I think it was in our it was in our second, actually, the second out of the 4 projects that Jan mentioned, where we conceptualized a system as a form of a recommender system using machine learning algorithms in order to do this. So the initial idea is that we had this simplified structure that we feed a specific machine learning algorithm with errors, deficiencies, and damages. And what we get out of this as an outcome is a self-inspection list. And just to let you know, when we say self-inspection list, it has to do with the legal framework of Sweden of how quality audits and quality inspections are made, where contractors and specific like quality surveyors have lists that they need to check regarding specific quality intensive issues regarding the project. Is this built correctly? Is this pipe in the correct position? Are there some specific like quality thresholds that are taken up? But of course, as Jan has explained, this is not enough. This like way that the quality self-inspection process works in Sweden is not enough. So we figured that there's a lot of data that is being siloed and not necessarily used, because data can be collected. We have examples of companies, both large and also medium companies, that actually have data collection systems, but then data is just siloed and it's not used. And our initial idea was that, okay, so if we can study the particular context of a company and use the data that this company has in order to train a specific tailored machine learning system, then we can create some kind of self-inspection lists that can be used then for by quality surveyors for the project of that specific company. And of course, this system could be refined into recommendations in a way that, okay, if we have a specific type of project, then this is the self-inspection list you might want to use. And if you have another type of project, another type of building or construction project, this is the list that you might want to use, right? So this was a good idea, right? And it was also in 2019, 2020, right square into the machine learning craze. But the problem we learned is this, and we kind of learned this problem also working in our next project, the third one, the next to last of our projects, is that this intensive process is difficult to manage from the perspective of a company. So we could develop that for them, bringing in like academia and the wild thinking of academia and also the insights and the grounded understanding of the industry. We could conceptualize a system. We have actually produced mathematical models that could work with this type of data. But the problem is that this, after some point, becomes too contextualized. So to create a product that can do this, a generic product that can then, after its production, can be contextualized per company would be quite difficult because of the very specific field and the very specific nature of the data we're looking into. It would be like easier to create an individual in-house system for one company or the other, rather than create a product that could be trained by the different data sets of each companies and create something that is actually accurate enough for the for usage in the quality audits that this company would have to go through. So this was a problem. This system, this conceptualization with machine learning will probably be very accurate for a specific context of a specific company or organization, but then to create something that could be generic and contextualized afterwards would be quite difficult. And then we were racking our brains about it, how we can do this. In our third project, as I said before, we talked with clients, with construction clients or project owners in Sweden, and tried to see what would be important for them. What if we had such a system that helped them create quality checklists that can then be used by their quality surveyors or quality inspectors? What would be the interesting thing and what would be the easy thing for them to do? And what we learned, among other things, is that what I want is a system, this is the client speaking now, what I want is a system that it is easy for me to understand and that it has some kind of baseline knowledge by itself, but then it can mold and contextualize and understand or create an understanding of this knowledge when I give data to this system on the get-go, right there and then. And of course, this, now we are talking about 2021, 2022, of course, this rang many bells because this is when ChatGPT came out. Or it's not when ChatGPT came out, but it's there where everyone started talking about it. So we started looking into LLMs and trying to see how can we use a generative AI and not an AI that is framed by a machine learning algorithm, but rather use generative AI in order to address these difficulties we just described, namely having a system that has a baseline knowledge of the specific context and the specific field we want to use it for, and then building on top of this knowledge can directly talk or interact, and this is where HDI comes in very strongly, interact with the user in a way where it can capitalize on its already known knowledge with the real-time data that is being fed by the client. So yeah, and this kind of leads to our final project, the ones we're using right now, and I will pass the torch over to Jan again.
Thank you. And when this thing came around, I was totally blown away because walking around so many years, not that dramatic, but trying to figure out how can we do this, our initial ideas, and then this technology just arrives in our lap, basically. And I think this is the benefit of working in industry. You're trying to, solve things, like you put duct tape on things and see if it actually holds, and you build these small prototypes, and it doesn't really have to be true, or you just have to keep that entrepreneurial mind somehow and try to build something that you think is going to work. And opposite to the machine learning model that we saw on the previous slide, the big thing here is that in the center we changed we substituted the algorithms for a huge LLM instead. And on the far left side, instead of having these huge data sets that are needed for machine learning, we can now instead use very project specific data that sort of explains what the project is about, and we could sort of dictate also what kind of data we would want from these projects in order to use the power of LLMs, basically, to still achieve the end result to the far right, which is the self-inspection list. So, but this also opened up a lot of questions, obviously, not just data hallucination, but also data privacy and God knows what. But we decided that we have to do something, and we have to build small prototypes and iterations to see if this app actually can be used for the purpose that we wanted. And as you might know, LLMs are mostly or GPT-based models are basically created to generate stuff. But I also found it very interesting that the capability of analyzing text, which I was looking for already back in 2018, and also to compare text or compare comments to self-inspection lists or self-inspection checks, has a lot of value to it if it can be used that way. So, and but the hardest thing now, I think, when we finished our project, is to predict how the future of LLMs is going to be. I'm not sure anyone knows that for exactly, in detail what's going to happen, but I'm pretty sure we're going to see a lot of more models that we have today, and also the whole open source perspective of it. Back in when ChatGPT was released, the open source scene wasn't that big, and especially those models weren't that capable. But then suddenly something happened that they're very capable of doing things now, which also opens up the opportunity to bring those models into your own company and build applications on top of them. And that would solve a lot of these data privacy issues, sending data over to these big companies in Silicon Valley. Then you can have that data in your own computer network instead. So,
guys, just to we are quite behind on time, so if you could kind of wrap up in the next minute or two, that'd be great, because we've got one more speaker.
Sure.
Thanks.
Right.
Do you want to start?
So yeah, I mean, corroborating what Jan said, is that what we learned is that at least in the construction industry, what is needed by the stakeholders in any given project is some kind of, at the same time, some kind of specificity, some kind of generality. So they want to have general tools with which they can interact with data and make sense with it. But then they also want these tools to be able to answer to them and help them in very specific ways in very specific projects. And using LLMs for HDI in our context, but in general, as it seems in construction applications, we can give that, because LLMs, they are trained in a specific way, but then because they are generative, they can react to the user using them in a specific way. So even if in our system, the way clients interact with the system and what the system generates as when it comes to self-inspection lists would be different compared to when a contractor would use the system, and so on and so forth. So there are many known unknowns and unknown unknowns, like Jan said, but we definitely see some kind of opportunity here. Generative AI is here to stay, and we definitely believe that we can thoroughly use it in our industry, exactly because it can give some benefits that more like older or more traditional AI approaches could not give for the needs of our sector. So that's it from me. Jan, I don't know if you have anything else before we...
Since we're behind, I think it covered pretty well.
Okay.
Thank you.
So thanks, everyone. We'll stop sharing now.
Thanks, guys. Appreciate it. We are quite behind, so I'm going to move very quickly on to Burcin. Apologies for being behind on the schedule for your presentation, but I will hand over to you. And
how much time do you have, Jennifer?
We were scheduled to finish at in 15 minutes, but I think we could just run for as long as people are available. I mean, I don't want to keep you longer than necessary, but if you're also happy to stay and answer one or two questions after, that would be great. So it's really dependent on you guys.
Okay, I'll try to be as quick as I can. I believe you can see me.
Yes.
I'm meaning the presentation, sorry.
Yeah.
So that was a great discussion and presentation. So I will focus more on the application of human data interaction within the context of human building interaction. And I'll explain why this is important, as well as bring some of the projects from our lab in terms of what we can do with HBI. Good morning, good afternoon, wherever you are today. My name is Burcin Becerik-Gerber. I'm a professor in the Civil and Environmental Engineering Department of University of Southern California. Today, I'm joining you from Los Angeles. So the talk today will focus on indoor environments as well as construction, with a specific focus on everyday spaces. I'd like you to think about your typical day for 30 seconds. Where do you spend your time? And are those environments, maybe it's your home, in your office, or a classroom, responsive to your preferences, responsive to your needs, or did they remain static and unresponsive? So I put this forward that as we enter the new era of AI, we have now the opportunity to redefine our built environments, making them more intelligent, sustainable, and centered around human needs. My group at USC focuses on responsive and adaptive built environments. These environments learn from you and adapts to your behavior, predicting and responding to your needs in real time. Sorry about that. And they interact with you in a natural, intuitive way and reason with clear objectives. What I mean by that is improving user satisfaction, comfort, productivity, safety, thereby improving your experiences in your spaces. So this was an effort of describing human building interaction with about 30 authors from multiple disciplines spanning engineering, data science, computer science, and social sciences. So AI is transforming the way we design, build, operate, and interact with our built environments, and providing these advanced tools that were mentioned in the previous presentations, as well as for data analysis, predictive modeling, on cognitive behavioral simulations. And now we have the capabilities to make more informed decisions and enable near real-time control of our built environments in ways that we prioritize individual needs, as I mentioned in the previous slide, but also achieving broader societal goals like equity, inclusion, and privacy preservation. And to realize these objectives is extremely crucial to build trust in AI and explore human-AI collaborations. So I'll skip slides and focus on a couple projects to give you a sense of how human building interaction could be enabled within our built environments. So this goes to our earlier work where we were trying to mathematically model thermal comfort from participatory sensing to the gentleman in the middle has infrared sensors. Of course, we moved to thermal cameras later on and the wearables. But imagine if your building could anticipate when you might become uncomfortable and proactively adjust the temperature before you even notice the change. And this is also earlier work where we have looked at the building elements themselves to adapt your preferences. So this is an architectural space with a kinetic facade that adjusts in real time based on user preferences, with energy efficiency as another objective as you enter the room. Later on, we looked at if we can rethink very simple objects and embed intelligence within them. And here you see a collaboration with a global engineering firm, Arup, where we developed an intelligent desk equipped with multiple sensors to model, learn, and monitor users, not only thermal comfort preferences, but also visual and postural comfort. So this desk adapts to their users, providing comfortable work environments through localized adjustments, such as a personal heater or fan or task lighting or ambient lighting, and negotiated with the occupants where needed. So this is a way of that negotiation we realized that not only the environment has to be personalized for our comfort, but also the level of automation had to be personalized, because we have different comfort levels in terms of level of automation. We tested here different levels of automation, going from manual to full automation and inquisitive and adaptive automation in between, where our test participants preferred inquisitive automation, which requires users to approve or decline the agent's adjustments. But in most cases, we also have to communicate with the user. Let that be related to your personal comfort to be expanded because of energy efficiency or other users' preferences, or it could be related to some kind of a postural adjustment. And we have checked what kind of interaction and personification would be most appropriate. And in this research, we personified both buildings and the building managers through text, voice, and avatar. We use female and male characters. This is a line of research which I'd be happy to share with you if you're interested, but our findings revealed that intelligent virtual agents were more effective than text or voice in terms of encouraging compliance with the building requests. And also, we tested what if we embedded social, relational factors in this. And we found that higher compliance were received from female communicators when they engaged through conversational interactions. Our lab right now focuses also on well-being. I don't know how much time I have, but I'll show one project which is related to stress. Stress is in literature mostly treated as negative stress, which is called de-stress. But there is also another type of stress, which is eustress, which arises in situations that are perceived as challenging but manageable. And that leads to your improved performance, personal growth, and satisfaction. So we wanted to be able to differentiate between eustress and de-stress, because the goal should be reducing de-stress and improving eustress. So this is an experiment in a lab, experimental study with about 50 participants. We use physiological behavioral data and develop machine learning algorithms. We processed data from wearable devices, as well as you can see, use computer vision algorithms to analyze facial expressions. One quick observation, unfortunately, I don't have time to dive into the details, was differences between female participants and male participants. Female participants perceive the task to be more on the eustress side than the de-stress side. But here are two graphs that show what data modalities are best suited for the prediction of eustress and de-stress. As you can see, gender was the second most important feature in the prediction of eustress. We also looked at stress and productivity. And fair enough, that relationship follows Yorkins-Dawson law. As you can see here, where there is when there's an absence of eustress and de-stress, there's boredom. When you have eustress, your productivity increases. On the right of that graph, when de-stress takes over, your productivity starts dropping. But these are short-term experiments. So right now we're in the process of actually collecting long-term multimodal data sets for modeling health in real-world buildings. So we're collecting data over 6 months from 30 participants to detect and map stress patterns across space and time. So we're looking at their home environments as well as in their office environments. And very recently, we have added and neurodivergent individuals in the data collection, because most of the buildings are developed, designed, and operated for neurotypical population, which does not include neurodivergent individuals who might have hyper or hyposensitivity towards indoor environmental quality factors such as lighting or colors or temperature and noise. I'll move very quickly to how we use these tools in safety and security. There are many interesting questions in terms of how behavior is influenced by a building design, type of a building, individuals' past experiences, and people around them, and who they're responsible for. So we use virtual reality for collecting data for emergencies because we found the ecological validity to be high, and it's really difficult to replicate emergencies in buildings. And we have a number of experiments that we have conducted with these methods, creating emergencies, different emergencies. The previous one was a fire emergency, a real fire emergency. This one is related to active shooter incidents. And we're trying to understand building attributes that are recommended to prevent or deter terrorism, affect human behavior. Again, we're looking at also individual factors like gender, education level, geographic region, because we collect data in multiple locations, including Europe, Asia, and North America. Moderate occupant responses. But the reason I am showing those are our goal is to create digital twins that are not limited by rule-based models. And just to explain the issue with that, rule-based models oversimplify agent behaviors, failing to capture the complexity of human decision-making, emotions, or social interactions, which are extremely important in emergencies. They're also homogeneous with little behavioral diversity, and their interactions with the environment are usually predefined, lacking the ability to adapt to dynamic changes that you would see, such as fire or debris in these kind of emergencies. So we are now in the process of capturing these behaviors using different methods like reinforcement learning to develop intelligent agents that are capable of simulating threats with occupants, threats and occupants with diverse abilities and decision-making processes. Our goal is to integrate these methods into widely used crowd simulation tools, and this one is Mass Motion. We're working again with Arup to be able to provide this cognitive agent integration to the designers and engineers who are making important decisions during the design phase. Lastly, I'd like to highlight a couple of projects that are related to human-robot collaboration on construction sites. As you're very familiar with the construction sites, and as you see in the slide, that every human-robot collaboration is extremely important because of the activities take place on the construction site. So there's several intriguing research questions arise in this context, such as what is the relationship between level of robot autonomy and trust in automation? Who assumes the leadership within a crew? Is it the operator? Is it the worker? Or is it the robot? How does collaboration between robots and workers transform construction workflows and such? But more importantly, reskilling and upskilling construction workers is very important as we have worker shortages in the construction industry. Here I'm showing you a VR-based training program that assesses each worker's skill levels and adjusts content based on their prior knowledge and adapts to individual learning needs by either repeating content and slowing down the delivery process as necessary. During the training process, we recognize the critical role of sensory information. So in another project, we're looking at not just the visual cues, but the sound, haptic feedback, even smell, to provide essential context about the structure, the construction site, and the surrounding environment, all of which are very important for enhancing safety and efficiency if we were to have remotely operated construction equipment. Anyway, I'll fast forward. I don't think we have a lot of time, but I want to point out some of the challenges that remain, and we must really address this as a research community and practitioners. There are ethical and privacy concerns when we implement AI in built environments, because even with simple air quality sensors, we can detect some personal factors, know who you're interacting with. So it goes beyond simply looking at carbon dioxide or VOC or PM levels. Integration with existing systems is extremely important. We have a large existing building system. How do we integrate AI with legacy systems in older buildings is an important question. Cost and accessibility is something I always think about, because these technologies shouldn't be just for the top 5% of the buildings, but we have to be able to make it accessible to a broader community of communities. And we are all excited about AI, but I also would like us to think about the computational power and the water required for these AI systems. They're very power and water hungry systems. So we want to make sure we're offsetting a goal achieved through AI-driven optimizations. So for example, energy savings and the implications. So I'll leave it here. I think that was about 18 minutes. I apologize if I went way too fast, but I'd be happy to answer your questions.
No, not at all. That was incredibly interesting, looking at different prospects, different applications, different technologies and things. Yeah. So thank you very much. So we are over time, but I think if people are happy to stick around for a bit, and particularly Mohamad, if you have a few minutes, maybe we'll do a short Q&A.
Of course, yeah. I think, let me know how much we have, Jenny. I don't mind, I don't have problem staying. So yeah, we'll start with the Q&A. If the people attending online have a question, please add them to the chat. I think really we had 3 great presentations on the complementary aspect related to the subject of HDI. I will, Richard said he can stay 10-15 minutes. I will start actually with Richard. I think, Richard, your presentation was great in terms of really like portraying a good landscape of the key issues in HDI, lack of agency, lack of negotiability, and lack of legibility. But then in your second part of your presentation, you started, because in the first part, I felt like, this is like too complicated. I was feeling, that like sense of, like pessimism, there is no solution to the problem. Then you started showing some, some potential solution, moving the code to the data, and you showed the federated learning. So my question is, where do you see the future? Do you think the future would be technology-led, like through things like federated learning, or you think the big shift will come from standard like GDPR or European or UK or international standard? Where do you see what do you see the future? How do you see it?
So I think, I was having a discussion about this in a different context yesterday. I think it's very difficult to put boundaries on systems and say this is where the system finishes. So I think that technical approaches like federated learning, like edge computing, I think they are more natural fits for some of the, for example, the regulatory environment, such as GDPR, for some of these kind of socio-technical systems questions. I think they fit better. But I don't think that they are solutions in their own right. You can't you won't solve all the problems in this space simply by saying, let's do edge computing and that'll be that. I think you'll need to have this kind of co-development between what society wants, what people want, the regulation, the legal frameworks, the constraints they put in place on the technologies, what technologies have to provide, and then what can be done with technologies. Some of the federated learning approaches, they're quite new. They're being actively developed. It's not something that would necessarily have been straightforward to do 10 years ago. The capability of mobile phones has increased over that time. So I think these things kind of all move together. I think it's important not to get too focused on one of those elements at the expense of all the others. I think you have to to be effective, you've got to sort of bear in mind all the different elements that are in play here, rather than just focusing on a single piece and saying, if we do this piece of technology, that will solve it. I think one of the things I think about some of the built environment stuff that was talking about as well is that it is about being, I think it's about being specific about, for this particular set of challenges, this particular environment, this particular context, who are the stakeholders, who does care, what are the constraints? There will be a different set of constraints for a system involved in construction and the built environment than there might be for social media and online privacy and things like that. They're just different environments, and you've got to take account of the specifics of that environment and the specifics of the stakeholders. The fact that a construction site is, there are clients and architects and designers and builders and contractors. The stakeholders are different than there might be in a domestic environment with IoT sensors and that sort of concern. So I think it is worth being, as I said, trying to be specific about it rather than thinking of these things as too generically. It's about data. It's about privacy. These are very generic concerns. I think it's helpful to be specific about.
Absolutely. I mean, if people have follow-up question, please spare them. I'll move to Dimos and Jan. Dimos and Jan, and I think you mentioned you developed this solution, and you said in your presentation you thought it's a good thing to deploy it more wider for other players, other construction companies. I mean, maybe you didn't have time to talk about that, but what was the experience from making this solution available to others? Did they engage with it? Did they have concern? What did you learn from deploying it or making it available to others within the construction sector? You are on mute, Dimos.
Yeah, thank you for this question, and I apologize for being muted without realizing that. Maybe there was some kind of misunderstanding. We didn't deploy the solution, but we worked on the prototype, right?
Okay.
But we approached, through our research, we talked with the clients, and we had a focus group, that was working with the project, and we talked, and we are continuously talking and trying to refine this prototype concepts with them, right? And we only have things that we are testing at the moment, so we didn't deploy it, right? But even in this testing phase that we are, and this prototypical development that we are in right now, we have already learned the things that we talked about in the presentation regarding, for example, the specific ways to mold the context depending on the user. But Jan?
No, I mean, we're just about on the finishing line now to start approaching those clients that we work with in previous projects that want to try this out. So we're actually on the starting line.
Yeah, a quick follow-up to you guys, maybe slightly more technical, because I'm looking into quite a lot these days in LLM. So you showed in your slide, Jan, that you have the data and you have the LLM. I guess you're using, I'm not sure if you're using ChatGPT, kind of. So if you're using ChatGPT, your data is, you are losing, negotiability, you are losing agency, your data is going into the deep end, and you don't know what happened with the data. I'm not familiar with ChatGPT terms, and I'm sure other construction company wouldn't be just willing to share data through that platform. Are you using? Tell us a little bit. I'm not sure if you can uncover a little bit what the solution look like. Is it ChatGPT or is it something more? Is it keep your data a little bit segregated from ChatGPT, or is it open LLMs that you are developing in house? What kind of solution is it?
Yeah, That's a really good question. And currently what we're doing is when we simply doing prototyping now. So we started out with GPT-4, but then moved on to open source models. So the Llama models we're using now, and we're using them through Grok. So we're still using, it's still disappearing somewhere up in the cloud. But definitely that, like the one of the possibilities that we were discovering, that bringing those smaller models to your own company in order to process these things like locally, I think that could be a way, you know, without having all these hardware that costs too much money.
Okay, great. You have a question in the chat. I think you look at it, think about it. We'll come back to you. Burcin, really great presentation. Some really cutting edge research in human data interaction. I think the key question. I mean, maybe this is me who does lots of quite applied, just applied research. How do you scale up these things from the lab to really commercial buildings? What kind of challenges you face when you try to scale them up, even during the research? When you deploy them with real user rather than like human subject within as part of the experiment. What kind of challenges you face? You are on mute, Burcin, if you.
I should know by now. I apologize. It's a great question. And admittedly, most of my earlier work has been more foundational. But very recently, I moved to not applied, but trying to engage more stakeholders in the process so it could be applied down the road. And the stress project is one of those examples. We're collecting data in the wild from not research participants that come to the lab to take a short experiment, but this is a months-long experiment. Similarly, on the construction projects, I have a stakeholder group of manufacturers of robot makers, manufacturers of robots, operators, contractors, and similarly on the emergency one, I am working with first responders as well as risk and safety experts in engineering firms. So you asked about the challenges, and the reason I mention all of this is that's one of the challenges, Mohamad. It's really difficult, at least in the United States, but I'm sure it's similar in the other parts of the world as well, to be able to work in a multidisciplinary environment. In all of these projects, by the way, I have occupational scientists, psychologists, computer scientists, and all kinds of engineers and architects. But on top of that, there is another disciplinarity, which is working with practicing professionals. So that's one of the challenges because it takes tremendous amount of time on their side as well as on the leading institutions. Another challenge is return on investment. So every time I talk about these questions, these projects, I get asked, okay, what is going to be my return on investment if I deploy these tools in my buildings, if I deploy these tools in my construction sites, right? So this is why I showed a little bit of the research related to productivity. I honestly wanted to stay away from this. I did my dissertation on return on investment of online collaboration and project management tools. I swore that I said I'm not going back to it. But because of these questions, I'm like, okay, here you go. I have to go back and quantify these things. I'm not interested in surveillance of knowing people like how productive they are, but that is my way of we have to do this because no building owner or facility manager will agree to deploy these technologies, or there are also IoT sensors existing in buildings. You use those in these ways if we don't prove the ROI to them. So that's another challenge. I'm sure there are many others that I'm not right now thinking about. Cost is another one, right? So we're now working in another project, how we can actually optimize costs and where we should place. What is the optimal location of these sensors? How many of these sensors we need, right? How can we get by with the least amount? and what type of sensors, right? We can make inferences, or do we need all type of sensors or certain type of sensors? So cost is, I think, another barrier or challenge, and we're working on those issues.
That's great. I think, yeah, we share many of the challenges, and I think we have much more restriction here on our side in Europe and UK, because most of our research proposal to be funded, they have something called impact, which is basically, so what will happen in terms of societal outcomes. So we struggle sometimes to push some really very interesting, very fascinating ideas like the one you mentioned. That's really good to hear. I think I'll come to Richard with a really very high level question. I think, if you think about it now, we have, like around, not really in relation to HDI, but I'm framing the question in relation to HDI. If you think about trade, for example, when we buy product and return products, we have consumer product law, we have a trading association who looks sometimes to the behavior of organization and all of that. I wonder, and despite this, we're still having quite a lot of problems in trade. Happened to me last week. I found myself like £40 are going from my bank account every month, and I haven't done anything. All what I have done, I purchased one-off small service, is a car report. So this company can still operate, exploit people from taking one boss, I agree, to one-off purchase, and they found themselves subscribed to £40 a month, open-ended. If you don't notice it, you keep paying it. So if you think about that in terms of data, where we will be, I don't know, in a few years when we all have really valuable data to share about ourselves, this data might be exploited. Who will protect the right of individuals sharing data, or will there be some incentive for people, like kind monetize or some sort of incentive to share data? But that as well might have another negative angle, might increase that divide. Now we talk about digital divide between those who are really intellectually capable in terms of have the intellectual capability to navigate the digital world, and those who don't for various reasons. So if we get towards this world that I'm describing in future, what implication in terms as well of divide and protection and all sorts of things?
So I guess, to some extent, it's not a question I can answer. I don't know what's going to happen there. I think some of the factors that play into that. So it was a challenge that was quite commonly made to us about the data box approach, this idea that you have a device which has your data or controls access to your data, that it's an atomization of society. So it puts it in the hands of the individual, and it becomes the individual's responsibility to control access, to understand the implications, to make informed decisions about what's going to happen. And in practice, that's too much. There's too much responsibility. It's too much expertise required of everybody to be able to do this. And so a better way of framing it might be, rather than as individual agency, would be to frame it in the terms of consumer protection. So the idea that as you have you go shopping in a supermarket, you buy food off the shelves, you're not responsible for checking that the food is not going to make you ill.
Yeah.
There's a whole regulatory environment and inspection infrastructure set up to try and make sure that when supermarkets sell you food, it's good. Best by dates, things like that. So there's a sort of a difference in the way that the environment should be constructed, the system should be constructed around the technical details, which will drive different technical solutions. And I think that's an important piece. I think in terms of the digital divide, I think it's already the case that this is abysmal. I had a PhD student at Nottingham who did some work on terms of service and the legibility of terms of service. And so she had a little plugin for a web browser that gave you the SMOG score, the readability score of a piece of text, and compared the piece of text based on its readability and its length to famous works of literature. And if you look at most of the terms of service for the standard kind of online services you might use, like Gmail and so forth, they are dozens of pages long. The readability, the reading age of them, the reading difficulty of them is typically that you require somebody to have tertiary level education, so degree level education, to be able to properly understand the language and the complexity of language used in them. This had interesting implications. Somebody else took that, I think she took that and used it with the energy companies in the UK as well for their terms of service. And they have a regulatory obligation to make their terms of service understandable to the person in the street. And I think somebody else took it and used it for the online gambling companies, where again, you're dealing with vulnerable individuals. And in all these cases, the readability, the understandability, the legibility of those terms of service was appallingly high. The legibility was appallingly low. The requirements on the reader were appallingly high. And I think that had some interesting implications in a legal context, because there's a notion, I think it's a notion in contract law, that you have to come to a mutually agreed understanding with the other party to the contract. And I think there was a real question to be asked about, is it the case that somebody ticking the box to say, yes, I'm signing up to this, do they genuinely understand what they're signing up to? In a context where I think it was something like half the UK population, adult population, doesn't have a degree. And yet you've got a contract document there, which is estimated to require at least degree level education to actually understand the content of that contract. So have you really made an informed decision when you signed up? Arguably not. And so I think, but again, that's not a technical issue. That's to do with the way that the law is framed around this, the protections that are put in place, and how we address that. And I think a big challenge around that, as you can see in the online advertising space and so forth, is that there are some extremely big companies which have a lot of market power. They have a lot of money, a lot of lobbying power to try and make sure that things don't go in a direction which will put the onus on them to behave in certain ways. At the same time, the regulators, as far as I can tell, quite often, although there's regulation increasingly now, like GDPR, the equivalent in California, the Japanese equivalent, and others around the world, there is regulation that's trying to protect and provide for some redress of its power imbalance. But the organizations that put in place to sort of operate that regulation often don't actually have the resources and the capacity to really apply themselves to push back hard. I think in some sense that the European Union is one of the few bodies that actually has done that effectively and does seem able to take on a serious fight with some of these big corporations to actually push back on behalf of individuals and on behalf of people, the populace. But I don't know where that's going to go.
Yeah, no, absolutely. This is really great, Richard. I think your presentation plus some of the comment you made in the Q&A, these are really great for that white papers, for the papers that we are working on, the HDI committee is working on. Demos and Jan, you have a question in the chat, and I think these are the last two questions. So the question in the chat for you, Demos, and a final question for Burcin. Demos, can you read? Are you able to see that chat?
So there's a question from Alex who's left, but he asked, do you see a possibility to apply this to the industry in which the data confirms that the regulation is well respected, as well as a new list of nice to have requirements are defined to satisfy the client's needs? You're on mute again, Demos.
Damn. All right. Okay. So I thought that only by doing this I could be unmuted. But anyway, I think that probably Jan would be much more equipped to answer this. But before pushing it over to him, I would like to say that there are other things that make a system like that salient and attractive to use, right? So do I see a possibility? Absolutely. Are there other things that need to be addressed? Of course. And one of these things is also the way this interfaces with the user. And another important aspect, we were already looking for this application that we're developing, because the application we're developing had already also had a previous part, which is like a cloud application, right? Without the LLM GPT part. We were also looking at gamification. How to make the involvement and engagement with the app attractive and fun, like Jan said in his comments. So yeah, I think that this can be used to test the compliance with the regulatory requirements, and yes, they can be used. It can be used by clients when they are bidding projects. So they can say that I would like to use this application or this app in order for us to be able to check on quality, because it makes it easy and fun for us to do so. So yeah, in short, I believe this is possible. But Jan, what would you say about it?
I don't know if I understood the question right. I guess we can't figure that out now, but I can try to answer it. So from the perspective and support from the system that we are imagining is exactly that the system will support the user when it comes to these regulatory requirements and laws and rules to follow. And that was the whole point from the beginning, that build a system that would support users, that they don't have to think too much about exactly what to do. Obviously, you know your trade, right? What you're going to do and the tasks and so on. But also it is kind of impossible to have all the to have a good perspective and deep understanding of everything to check for that specific project, if it's a housing project or if it's whatever it is. So that was our intent from the beginning, to build a support system, and LLMs have made that really possible today. But when having specific sets of data that could be poured into the LLM as a RAG pipeline, or however you want to infiltrate it.
That's great. Thank you. And I'm sure we really this is my last quick question really to Burcin, and then we'll close. Burcin, I like that avatar, male, female, you showed at the end, and how people engage more with the female avatar. I wonder if you are doing anything around, and you could share, of course, doing anything around multimodal AI. I'm imagining that avatar could be a facility manager who knows everything about the building. If that avatar is fed through multimodal AI, can know everything about occupancy, about issues, about anything about building. Is there anything you are doing in that space? Because I keep talking to colleagues and friends, and everyone seems to be moving towards multimodal AI. Are you doing anything in that space that you could share, or not yet?
Not yet,
Okay.
but something along those lines, that we have interest in explaining data to the building occupants. Because in most cases we find, and there's actually a question in the chat or Q&A related to privacy as well. And that's something that I recently became very, very interested in. And that question asks who should own the data, employers or employees. I don't know how much my opinion counts. I think employees should own, everybody should own their own data. But in fact, I recently learned that in the United States, if you're in an office building, employers own your data. Very interesting. Wow. Anyway, sorry, going back to your question in the multimodal AI perspective, I think we really need to also educate occupants and workers about what type of data is being collected and what kind of inferences could be made from those data points, right? Because I mean, looking at just with light sensors, we can tell what kind of shows people are watching in Netflix. I mean, it is very interesting that we can, these algorithms are so advanced that we can use some of these ambient sensors in different ways. So we have to also educate occupants. So coming back to the multimodal AI conversation, that's an idea that we entertained. We haven't done any work, not from the facilities manager's perspective, but from an AI that explains the data, their data to the occupant's perspective.
This is really great. Thank you very much, all our keynote speakers. I'll hand over to Jenny.
Yeah, thank you. Thank you to everybody. So Burcin, Dimos, Jan, Mohamad, Richard, for your amazing presentations. Also to everybody who joined us online, especially those that have stuck it out right to the end. So we were half an hour beyond schedule, but I think it's been some really interesting presentations. I'm very grateful to everybody for all the input and the effort, and also for Ranjit, who helped organize this with me and put together, the LinkedIn Live and everything. So thank you very much. I won't keep you any longer. The last thing is just to say is, if you are interested in more about what we do as a committee, then do get in touch with me, and we can continue discussions. But I think for that we will close out, and just thank you very much.
Thank you very much. Bye bye.
Thank you,
Thank you, everyone. Bye bye. Take care.